Hello and welcome to our channel again. Today we have Smart Fortwo 2008 with 451 series of chassis. So the vehicle has come to our garage with the symptom that the heating system or air conditioning system, blower motor, fan is not operating, or a fan is not working. So as you can see, engine is running, and this is the fan operating switch. So it's now on 0. So if I move that to number 1, nothing is happening. So the blower motor fan is not operating. If I move that to position 2, and also nothing is happening. Even if I move that to position 3, and nothing is happening. And even if I move that to position number 4, so nothing is happening. So today we are going to investigate that together. So to investigate this together, we firstly need the wiring diagram and see how the circuit operates. So first we are going to check the wiring diagram. Right. This is the wiring diagram for the air conditioning system of Smart Fortwo with the chassis series of 451. So this is the SAM, or signal acquisition and activation module, this one. So the power is supplied through this fuse number 4, and it's rated 25 amps through this connector 1 at the SAM unit, or at the SAM module. Pin number 1, this one, pin number 1, connector 1 here. And this is going to be red and gray wire. And it's the power goes through this connector, 2-wire connector, this one, X85/10, and goes straight to the heater blower motor here. And coming out of heater blower motor. And as you can see, let me highlight this side. So this is the splice mark, and also that's here splice mark here. So one side of the connector here at the heater blower motor, a single wire, which is the input voltage to the motor. So the other side of the connector, pin 2, is joined with 2 blue wires, same color wires. So this splice is joined here. As you can see, it's a Z5/1, and also this one is Z5/1 too. So the current or power goes here and then through this resistor pack. So the ground for the heater blower motor is provided through the fan operating switch. So it's marked S98/1, and it's going to be here, as you can see, this one. So if I highlight this is the fan switch or heater blower motor switch. So the ground is switching to our right opposition. For example, when you move the fan switch to position 1, so the ground is going to be provided by for this motor by this gray wire, this. And at this stage, the motor will operate at low speed. So when you move, so the ground is going to be provided here through the switch, and here back, this is going to be black or brown wire. Here in the United Kingdom, it's going to be brown. Yeah, it's actually brown here after the connector, and after the connector to the ground side, it's going to be brown color. So it's brown color after the this connector towards the ground point. This is going to be the ground point, and here okay, it's a brown color after this connector until to the arc point where it's grounded to the chassis, and here it's black color up to the fan switch. So when the fan switch is moved to position number 2, so the ground is going to be provided by this yellow line for the heater blower motor through the fan switch going to through pin 5 here and to the ground. So when the fan switch is moved to position 3, so the ground for the heater blower motor for this one is going to be provided through the green wire, through this wire. So at this stage, the heater blower motor is going to be faster than this one, and faster than this one too. So this is going to be the lowest speed. The motor, the heater blower motor, is going to be at its lowest speed when the circuit of the heater blower motor is grounded through this gray wire. And when the circuit of the blower motor is grounded through this wire, it's going to be faster than the lowest one. So the speed of the heater blower motor is switched from lowest to the highest by the fan switch. So when the fan switch is moved to position 3, so the heater blower motor or the fan speed is going to be at a higher speed. And as you can see, the current will flow through just one resistor. So the lowest resistance in the circuits, the higher the current will flow. So when the fan switch is moved to position 4 or at high speed, heater blower fan at high speed, the current, this current from here, this is spliced as you saw at the connector, this will go here through the contact which is provided here by the fan switch to the arc point through this wire, through the connector here, and to the ground. So when the heater blower motor fan switches at position 4, current will go through this, and because this are no longer connected to the ground. Okay. In conclusion, so the power goes from the sum module or signal acquisition and activation module through this fuse, which is rated 25 amps, and the fuse number is 4, and it goes through this connector through the heater blower motor and through the heater blower motor here, and this two wire are joined just at this connector. So as you saw, they are joined here, and then the ground for the heater blower motor is going to be switched by the heater blower fan switch here. So when the heater blower motor fan is at low switch, the current will flow through this wire because there are 3 resistance. When the heater blower motor speed is a little bit higher and the fan switch, heater blower motor fan switch is at position 2, the current will flow through this switch, and then when the fan switch is moved to position 3 here, to position 3, the current will flow through this green wire to the earth or to the ground. When the fan switch is moved to position 4 here, so the heater blower motor will be grounded through this wire and this are together. This wire, these wires this and this are joined together. So our problem is here. So the power is reaching the heater blower motor, but the voltage, the current is not going through the motors because of the high resistance or open circuit. So when the resistance is high for any reason, so the current cannot flow, or if the circuit is open here, current will not flow. Okay, so permanent live wire is connected to this box here. As you can see, this is permanent live wire, and then power goes to the heater blower motor through this fuse, as you can see, through this fuse, which is rated 25 amps, fuse number 4. As you can see, this is the fuse. So power goes to the heater blower motor through this fuse, fuse number 4, which is rated 25 amps. From the fuse, it's coming through this wire. So this is some module, or this one, or signal acquisition and activation module, this one. So the fuse is located here. When you turn the ignition on, so power supplies through the fuse number 4, which is 25 amp rated, through this let me show you that, through this red and black wire, this one, and through this wire to the motor, and this is going to be the motor input, this one. So power input to the heater blower motor, the red wire, and then this is the heater blower motor fan, and the current coming out, or output. There are 2 blue wire. If you can see, they are just joined at the connector when the power is going out of the heater blower motor. So there are 2 wires, then branch it. So one has gone here, this one here, to pin number 4 at the resistor pack, this one of this blue wire, one of this, and the other blue wire has gone through the switch, and it's connected through position number 4 of the switch, position number 4, as you can see, and coming here from the heater blower fan switch, and through this connector, and going back through this brown color wire to the earth. So the speed of the heater blower motor is controlled by this resistor pack. So when you move the heater blower motor fan switch to position number 1, so this is 0 now, to position number 1, and the current coming out of the heater blower motor through this through this blue wire, and here through this blue wire, this blue wire, and going through this gray wire to the earth through this position number 1 switch here, when the switch is at position number 1. So if I move the fan switch to position number 2, this is position number 2, and the current is coming through this blue wire, and then going through this yellow wire to the ground, and it's grounded, or the ground part is provided through position 2, and routed here through this black wire, and going to the earth through this brown wire. And now the heater blower motor will operate a little bit faster than the position number 1. So if I move this to position number 3, and the current will be routed to the earth or to the ground through this yellow wire through this position number 3 of the heater blower fan switch. If I move that to position number 4, and the current is no longer connected or directed to the earth through this blue. Instead, this one wire has gone to position number 4 of the switch, and the current is routed through this position number 4 through this black wire here and through this brown to the earth point, this brown to the earth point. So now I'm going to carry out test. Okay, as you can see, this is the fuse number 4, this one. So as you can see, it's rated 25 amps. So I'm going to check that one, see if that's alive. So the engine is running, and as you can see, the fuse, one side of the fuse is alive, and I'm going to move to the other side of the fuse. So as you can see, the other side of the fuse is also alive, so it means that the fuse is okay. Now this is the connector, as I have shown you. This is the connector. So this has gone to the earth, the brown wire. As you can see, the brown wire has gone to earth, and this has gone to the motor. So I'm going to check here as well. So one second. As you can see, this is all right, and now I'm going to check the other side of the fuse, the connector. As you can see, the other side of the connector is okay. So the so far so good. And now I'm going to check. I'm not sure if you can see that. One second. The motor. So it's there. So it's there. That one. So this one. So I'm going to check the red wire first. Okay, as you can see, I have connected this back probe, the red back probe, to the blower motor input, and here, as you can see, the voltage is reaching the motor to the blower fan, to the blower motor fan. So now I'm going to check the output from the blower motor to the resistor pack. So as you can see, I have connected this tester light so to the wire, which is the output wire from the blower motor fan. And so I'm going to show you there. As you can see, I have connected the probe to the blue wire. As you can see, you might be able to see, and this is the output from the blower motor fan. So it means that the circuit is open within the blower motor fan. So if the circuit was closed, we should have had a voltage there available. So it means that the circuit is open. And also I'm going to show you that how the ground path is changing when you turn this fan operating switch to different position. So as you can see, ignition is on, but this one is not lighting, so the tester light is not lighting up. So I'm going to disconnect this one. As you can see, I have removed this. And this one with me. I'll be able to show you. Okay. So this is the resistor pack. So if I move the fan switch to position 1, so the grey wire is going to be connected to the ground. If I move the fan switch to position number 2, the yellow wire is going to be connected to ground. If I move the fan switch to position number 3, the green wire is going to be connected. If I move the fan to position number 4, so this wire, the current will not flow through the resistor. It's going to be connected straight to the earth through the switch. Okay, this tester light is connected to the battery positive. If I touch that here, as you can see, to ground, it's going to, as you can see, when I touches the test light to a ground. So this is pin 4 and this is pin 3, this is pin 2, this is pin 1. So now if I connect this here, let's let me connect this here. Bloody hell. So if I move this to position number 1, and now I'm going to check that this is connected to the battery positive and see that which wire is connected to the ground. So this is pin 4 and this is pin 3 and this is pin 2, as you can see. So the ground path is provided by the gray color wire, as you can see. So now I'm going to turn this switch back to any position. So I'm going to move that to, 1 second, I'm going to move that to 0 back, and as you can see the switch is off. If I move that back to position 1, the ground path is provided. If I move that to position 2, off. If I move that to position 3, off. If I move that to position 4, off. Now I'm going to bring that back to, so 1 back to 0, and now I'm going to move that to position 2. So it's 1 second, 1 2. So 2, it's going to be the yellow, as you can see, yellow wire provided path for the blower motor to position 2. Now I'm going to move that to position 3. So now the light is off, and if I move that to here, now the ground path is provided by green wire. So if I move that to position 4, so 4, now the ground path is provided by this 4, because the current will no longer flow through the resistor pack. It's going to flow directly through this switch, So we have found that this motor has open circuit within the winding, so we are going to replace that. To replace the motor, so first you need to remove this from here, then there is another cover you need to remove, that one. So you need to remove this cover as well. So then disconnect this two wire, so there are two screws, one here, and then disconnect this one, and disconnect the DLC connector from here. To disconnect the DLC connector, you need to move this backward, as you can see, move this way, and then the connector will be disconnected. So after that, when you have done this, then you need to bring the SAM module down to have access to the blower motor to be removed. And after that, you have moved the SAM module down, then you need to move this little bit outward to make this motor to turn anti-clockwise this way. Then move this outward and turn this anti-clockwise. So then the motor will be disconnected from its cage. And before you do that, you need to disconnect the motor as well. Motor wiring connect. Okay, to remove this down, there are two screws here, and that's the screws are here. One is here, and then connect. There is a latch at the back of the SAM module. I'm going to show you later. So then you need to twist this anti-clockwise and then remove like so. You need to remove from here. You cannot remove from here. You need to remove it here. You can see my hand from here, and so this is the latch here. This one you need to, when you remove these two screws, this is that? I cannot see. There's two screws, one this, one that. Then just gonna move this latch to the rearward of the vehicle, and this is going to be detached. Then turn this anti-clockwise, and then it's going to be detached. Okay, this is the one which I have just removed from the vehicle, and this is the one, this one I'm going to install to the vehicle. So now if I show you the resistance of this motor, as you can see, it's showing 4.37. And on this one, which I have just removed, I'm going to show you. As you can see, it's point. The resistance is actually the same, but yeah, this one is high. It's yeah, as you can see, this one is high, and this is the one I'm going to install. This is with the low resistance, as you can see. As you can see, now it has gone to 13, 11. So anyway, this is faulty, and this one is I'm going to install it. Okay, to install the motor, you need to put the motor in this direction, then you will feel in your hand that it's aligned or lined up. Then you need to twist that clockwise, and then this will position in this direction. This connector will position when this one is installed, and also you might be able to see this one is aligned to the other side of the cover. Okay, as you can see, ignition switch is on. Let me turn it off, on again. So ignition is on, and the pan switch is to position 1. You might be able to hear. So I'm going to move to position 2, 3, 4. And the blower motor fan is operating nicely. So thanks for watching.